right, let's get started. Our goals today: get the correct statistics for your analyses, okay? Make APA quality figures, right? And understand the results before you leave here so that you can effectively write your discussion. I cannot tell you how many lab reports I've read that I'm like, this person doesn't know what we did in this experiment. Which is a real shame, because you can't talk about the implications of something if you don't understand really what it is you did and you found, right? And that becomes really clear to me when I'm reading a discussion section. So it's important that you really have wrapped your mind around what it is that we did and what we found. Cool? Okay, so to recap, our independent variables, the things that we manipulated.
Presence of red light.
No light, red light. Okay, what else?
All color. Like.
Yes. The text color. Okay, so first of all, no light, red light. Between subject or within subject? Between subject. All right, you have one or the other. How many levels is it? 2. Text color, between subject, within subject. Everybody did all 3 colors, right? 3 levels, red, blue, green. Cool? One last one we're going to include. Stimulus sets were different. They were between, right, and 2 levels. And so, what are you expecting to find for each of these? First of all, the stimulus set. What do you want to find for that variable when we do statistics? We want it not to be significant, right? If it's significant, what does that mean? Yeah, that they weren't balanced, right? That one had a difference in our dependent variables than the other. So this we really want to see. Sometimes not seeing a significant effect is important. Okay? What about for red light, no light? What would you predict? Why would you predict no difference?
It's the adaptation. Your rods can't detect red light, and so it's the same reading with the red light versus between the dark.
Yeah, so if rods are insensitive to red light, meaning they can't be bleached, meaning rhodopsin can build up in red light just as easily as it can in dark and no light. If that is true, then we would expect not to see a significant effect here. Again, another thing that's important, it's not always looking for significance, it's important. It's understanding what you're looking at, right? Okay. What about blue, green, and red? Well, first of all, let's define our dependent variables. So, what are our dependent variables? Time. So we had 2 time measurements, right? We had time to read each word, okay? That is going to be your figure 1. There are, we're going to have no stats with that. I'll talk about that. Blessings. What else did we measure? The threshold, right? Everybody typed in, what is the minimum intensity I got to? Also known as threshold, right? Figure 2. We'll have stats with that. And then what was the third thing that we measured? Time to threshold. That's going to be your figure 3. We'll have stacks with that. Okay. Are we good so far? Okay. Oh, back to here real quick. Blue, green, and red. Do you predict a difference in the threshold for each of those 3?
Yes.
Why would you predict a difference in the threshold? The rod sensitivity to blue, green, and red is different. What do we say about red? It's insensitive, so you would expect the threshold to be highest for red, right? What do we know about the sensitivity to blue and green? The highest sensitivity is for green, right? Which would also then mean the lowest threshold. And blue should be somewhere in between green and red, right? And then we'll talk about time to get to threshold a little bit more. That'll be one of the ones that I want to make sure that you're really clear on that before you leave here today, okay? All right, so let's start with dependent variable 1, figure 1. If you go to the middle page, you'll see, hey, figure 1's right here waiting for me. What did Dr. Pittman do? So if you open up figure 1, hopefully you guys can see that okay. Well, while I have it all on here, let me just point out a couple of things. I made this figure for you, you're welcome, for 2 reasons. One, making these graphs is not intuitive and a little bit difficult. And I don't want to spend an hour trying to show you how to make a graph that you'll never make again, probably. Okay? So, I'll go over the graphs in just a second. But number 2, I want to be crystal clear what APA format looks like for figures. The figures come, each figure on its own separate page at the very end of your document after the reference section. Which reminds me, I never sent y'all how to cite my PowerPoint slides. So somebody email me to do that, please. Or I will forget again. I will do that. Okay. So, each figure on its own page, and this is the format. It's APA, you know this, it's very, very specific, okay? Bold, figure 1. Is there a period? No, there's not. Is there anything else on that line? No, there's not. Next line, not bold, but italicized, the figure title. The title should be descriptive of what you're looking at in the figure. Here we have 3 different panels, an A, B, and C. Then we have our note. The word note, does it have a period? Yes, it does. Is it italicized?
Yes.
Yes. Is the rest of the note italicized? No. Okay? You'd think that this, we wouldn't have to do this, but trust me. Okay. And then in the note, it's kind of like your figure caption. That is going to tell you descriptions of what you need to know to understand this, like these are the average times plus or minus the standard error of ours there, right? The time to detect each stimulus intensity, right? Time to detect the stimulus intensity for each color, green, blue, and red, under 3 different conditions, right? So A, now I'm going to blow this up a little bit so we can see. Okay. So A are both light conditions together. So not separating out red light, no light, but if we just look at them together, okay? And what we see is very short time, right, low time, near 0, to recognize the first stimulus. as the stimulus intensity goes down, right, it takes incrementally longer to see the blue than the green and the red than the green. And in fact, at some point around here, people quit being able to see red, and we have no data points below this intensity. Right? Okay. The slopes of those lines represent the speed at which you were reading those words. The flatter the slope, the faster you were. So green, all the way down here to a very low stimulus, is around under 100 seconds. Very fast to get down there. To get to the same stimulus, it took considerably longer, close to 600 seconds for blue. So this is really the way you can talk about the speed of adaptation as opposed to the threshold or the time you get to threshold. The speed of the process of dark adaptation for each of those three colors. Are we good? Questions? Okay. Okay, so now we have the no light condition and the red light condition. And essentially these are correlations. These numbers on here are correlating the intensity to the time, right? And so there are R-square values. I said there's no statistics. I don't want you to report these, but I want you to understand, right, that these R-square values are very high, right? And that represents the fit of those lines to the data. Fit of those lines to the data, right? You'll notice the R-square for blue, for instance, is really high, 0.94. The Hessian gets 1, right? And look at the line. It's sitting right on all the data points until we get to these last two that are kind of out here, right? If you notice for red and for green, it's a lower number. It's still high, but 78 is lower than 94. But if you look at this, right, out here, we sort of go all over the place, so the line doesn't fit very well. The line doesn't come up and then dive down, right? And over here, the line fits real well until we get to these last 2 points and it shoots way up. Right? So these R-squares are how well does that line represent the overall data? And the answer is very well. Okay? Do you all understand that? Okay. And if we compare this and this, I tried overlaying them and it just gets messy with 6 lines all on the same graph. So it's just easier to be here. But essentially there's no difference. Essentially there's no difference in the speed at which you're doing this under red light conditions, bright red light, or under pitch black and no light. So this variable did not affect the speed of dark adaptation. Are we good? Okay, so everybody can describe the results for figure 1. Even though I'm giving you the figure, you still have to write your results. That's a section in your results section, a paragraph of describing what the results are here in terms of speed of adaptation and the effect of no light or red light.
So in our results, do you want us to use that R squared and or
No.
just kind of explain it and say, let's see figure 1?
Yes. I want you to talk about the slope of the lines representing the speed of adaptation for the 3 different color text and for the no light, red light. You do not need to put any of these numbers in your results section. Okay? That's why I said no stats on this. Yes, sir?
So the figure 1 is going to be all 3 of these graphs?
This is figure 1.
Page.
You are going to take this and you are going to copy and paste it into your lab report as figure 1. That is it's not plagiarism, I'm giving you a gift of figure 1. Please make figure 2 and 3 look like figure 1 in terms of APA format. Okay, I'm modeling this for you. Okay, so you may copy and paste this into your lab report as your figure 1.
Does that include the note part of figure 1?
Yeah, a note part's fine. The whole thing. I'm giving you the whole thing. With my permission. Okay? Good? Yes?
Does that mean you're okay with us using color in the graphs? Because I know sometimes people want black and white.
Yeah. So I'm okay with using color because you're not going to print this out in black and white and give it to me. If you're going to print out a black and white copy, then I want grayscale so I can see the differences, right? But I'm going to get this in color from you as an electronic file, so I'm okay with that. Yeah. Okay. All right, good. All right, can we check this off? Okay, good. Making progress. Okay, now we need to come over here where it says group data 2026, and that is an SPS file. You need to download that file and open it in SPSS. If anyone's SPSS is not working, you can grab a laptop over there. SPSS is not Okay. I know that takes a little while to open up, but when it opens up, this is what you should see. Okay. Everybody got it opened up? Okay. So, minimum intensity threshold, right? That would be this column, blue men, green men, red men, right? Set 1 or 2. Set 1 or 2. Okay. Lights. 0 is no light. 1 is red light. Right. Those are between subject variables. Right. Because we have a within subject variable, that means we repeatedly measured something, and we have more than two variables. So we can do a t-test. What kind of test do we want to do for this type of data? An ANOVA, what kind of ANOVA? A repeated measures ANOVA, right? Okay, and where do you find that in SPSS? And I gave everybody a cheat sheet of quick steps to run in an ANOVA, so you should have that in front of you. So you should be able to follow that. I really hope I don't have to walk you guys through this, but you can follow that and go. Everybody feel confident doing that? Is anyone not feeling confident? Do you want me to show you the first one? No, you're good. Yes? So y'all tell me what to do. I'll be the sophomore student taking stats. What do I do? What do I click on first? Analyze, and then what? General linear model, and then repeated measures. Okay? Now, what do I do in this box? All right, this box does what? Defines our Which variables? Which independent? Yes, the within subject variables, right? So our within subject variable was text color. How many levels did we have?
3.
Okay, should I put 3 here?
Yes.
Thank you. Okay. Do we have any other within subject variables?
No.
Okay, so we can click define. Okay, now, in this window, what's the first thing I want to do? I got to define what those 3 variables are. So we said that those are blue men, green men, and red men. Right? So I want to move those over. Okay? Am I done? What do I need to do next? I need to define my between subjects factors. This half of the room is being quiet. What are my between subject factors? The lights and the set, right? So I want to move set and lights over. We're not going to do here. Crazy. Okay. Am I done now? I've defined my within and my between. Am I done? What's the next step? There's some buttons over here, right? Do I need to push some of those? What do I need to push? What does post hoc tell me? Yeah? That's the type of test it is, a type of test. No, that's close enough. So, post hocs are only for my between subject variables. Okay? How many levels are each of those? 2. So if there's a significant effect of set, do I know what's different from what? How many variables do I have? 2. So if there's a significant difference, it means set 1 is different from set 2. I got to go look and see if it's higher or lower, but it tells me what it is, right? If there's a significant effect of lights, I know it has to be no light versus red light. We didn't have a blue light condition, right? If we had a red light, blue light, no light condition, and it was significant, how would I know which of the 3 is different from one another? I can't just tell, it just means that one or more are different. How do I know which ones are different? That's when you have to do a post hoc test. So you don't need to do a post hoc test if all your between subject variables are 2 levels, because it's worthless. I mean, it's not going to tell you any more information. But if I have 3 or more, the post hoc will tell me which ones are different from each other. Okay? So we don't need to do that. EM means, what is that? Do we want that? Yes, we do. Okay? And for EM means, we always want to use all of the main effects and interactions. These are all the main effects and interactions. So after you get your main stats, the estimated marginal means is all that junk below there that tells you what are the means for these different interactions and stimulus things. And main effects. So the easiest way to do that is to select all of them. So on a PC, you can do Control A. On a Mac, I think it's that funny little cloverleaf thing in A. But that selects everything, and then you can move them over. Right? And we're going to compare both. It's fine. And we're going to choose Bonferroni instead of LSD. Why do we not choose LSD? Dad joke for the day is you don't do drugs. Least significant differences, right? Doesn't account for multiple comparisons. So if we're doing lots of post hoc t-tests, we're generating lots of p-values, and that sort of artificially inflates that alpha number of 0.05. Bonferroni corrects for how many it's doing, which means it makes it a little bit harder, but it's better, okay? So think about the B for Bonferroni is better. Okay, continue. Very good. All right, under options, we probably won't use these, but it's a good habit to get into to click those first 3 boxes. Because sometimes you do want to know what your effect size was or what your power was, or you want to look at the descriptive stats. And if you don't click those, then you got to go back and redo it just to see those numbers. So it's just a good practice habit to click those 3 boxes. Cool? Continue, and now we're okay. All right, so we let SPSS do the work. And what is the first thing that I want to do? When I get an output? Save it. I want to redo our work, right?
You want to go to assessment within subjects effects?
What's that?
You want to go within subjects effects?
Yeah, so our first stats are going to be at the within subject effects, but while we're here, what information do I want to get? While we're at this top screen, what are we looking at here?
What number got assigned to each thing, to each factor?
Yeah, so we want to know that 0 is no light. Is that what you're talking about? And 1 is red light?
And the 1, 2, 3 color.
Yeah, and the text color 1, 2, 3 is blue, green, red. Yeah. What else information is here that's important for your lab report? Yeah, we're actually going to get those. These are our descriptive sets. We're going to get those means and standard deviations. We're going to use the estimated marginal means for those. Yes, our sample size. This is where you find your sample size. Right? So what is our sample size? How many total subjects were there? Hopefully this is up on your screen. How many total subjects? 312. This number here. Total. 312. If you add up these, what does that add up to? If you add up these, what does that add up to? Right? So we have 312, and how would you write that in your lab report? Yeah, so do we have subsets of subjects in here? Yeah, we got red light, no light, and so on. So when we're doing that, right, we're going to use italicized. Stats are always italicized. P, F, N, always italicized. Okay? But capital N is 312. And then if we want to talk about step 1, we can use lowercase n. It's hard to handwrite italicized. Right? And then we have red light was 155. No light had 2 more. Right? So those are all everything you need for your sample size. Where does that go in your lab report? In the method, right? That's method, but you got to get it from your results. Right? Sometimes in your thesis, maybe you collected 325 subjects, but some of them got thrown out of the analysis. So it's not always, you want to report your sample size that your results are coming from. Now you may say we recruited 325 people and had to exclude 13, and so our sample size was this. Right? Cool? Okay. So, as you said before, there are 2 important There's a lot of stuff. Part of learning to use SPSS is learning how to ignore the proper things that you want to ignore and look at the meaningful things you want to look at, right? The meaningful things are tested within subject effects and tested between subject effects. Effects, not contrasts. Okay? So we look at our tester within subject effects, and what are the important things that I'm looking at here? So first of all, we're always going to use the top one of these. These are corrected things. We're going to assume that we're cool and use that top one, right? So for text color, do we find a significant effect? Where do you see that, right? So what do I need to report in my results section? But what am I reporting number-wise out of here as my stat in my results section? What's that? Yeah. Degrees of freedom. And what? Yeah, let's do it in order. So we're going to have F, and then in parentheses, there's two numbers. The first one's degrees of freedom. What's the second one? How long ago did you take 160? Or is it 160? 166. Air. Okay. So in those parentheses, you would have 2,616. Right? Then we do equals the F value. Comma, or italicized P, and here it's less than 0.001. If it were more, if it were under 0.05, but higher than that, we would report the actual p-value. But here it's less than 0.01. We good? So we got a main effect of text color. Okay. Were any of the interactions, text color and set, text color and lights, or text color set and lights, were any of those significant? No. Right? So no, no, and no. Right? Good? Okay. Spoiler alert, you're going to do the same thing for time to reach threshold. We'll get there. So I'm not going to do that. All right. What about our between subject effects? Where do we look for significance? Right here, right? Was the set or the lights or the interaction between the two significant? No. Right? So is that a good or bad thing? It's a good thing, right? It's telling us that whether the red light's on or not is not a significant effect. Whether you use set 1 or set 2 is not a significant effect. So what was the significant effect we found? Text color. What were the text colors? Blue, red, and green. We have 3. How do we know which ones were different? That's why we did the estimated marginal means, right? So we want to come down here to text color. Come down here to text color. Let's click on that. And not post-hoc, but pairwise comparisons. It's a type of post-hoc test. Okay? This is where we click Bonferroni. It's doing adjusted tests. One is blue. Is it significantly different from green and red? Blue different from green? Yes. Blue different from red? Yes. What's the one comparison we haven't compared? Green versus red. Is it significant? So all three of them are significantly different from each other. So normally, because there's no interactions, this is what you would graph. Blue, green, and red threshold. Right? Look at those numbers. Does that support or not support our hypothesis? What was our hypothesis in terms of threshold? I think it was sensitivity. Highest threshold for red because rods can't detect red. Right? Lowest threshold for what? Green. Highest sensitivity of rods is for green. Lowest threshold. And blue is in between. Right? Now, what I would like you to do, so we are good on our, I like checking things off. It makes you feel like we're making progress. So we're good on that, right? In terms of graphing your figure 2, I would like you to graph the set by text, no, not set, lights by text color. So we come down here to find lights by text color. I would like you to graph each of the thresholds for no light and red light, just so you can demonstrate how similar they were, that red light doesn't produce an effect. So even though that wasn't a significant interaction, I'd like you to graph that for this. So this is going to be text by lights. Right? And so you can take and copy this. You can copy that and put it in Excel. Here's a trick with SPSS. If I just paste this in there, that's what it looks like. It's kind of messy. It's got all this formatting stuff, right? But if I say paste as like plain text here, the little clipboard thing, then it's much like, it's unformatted. It's much easier. And so I have my means and I have my standard errors. We can't just select all that and say graph that. If we do that, right, this is what we get. Does that look like something we want? No, right? So we have to put that in a usable chart format. So how do we do that? First of all, what type of chart do we want to make for this? A bar graph. Why not a line graph? Yeah, because we're not looking across a continual stimulus, right? So a bar graph is appropriate because they're separate categories of things. They're not connected to each other in some way, right? So we can come over here and we can say, you can do this in a number of different ways, right? But you could say, we can make it easy and do blue, green, red, and we can do no light, and we can do red light. And now, a matrix like this, we can graph that, right? Excel likes that, right? So my no light means are right here. Right? So I can just copy and paste those there. And my red light are there, copy and paste that there. And now, if I put in a graph, right, does that look more like something that we would want? We have blue, we have green, and we have red, and we're comparing no light and red light for each of those. And do they look very similar? Yes. The thresholds are very similar. All right, flip your little paper over. And I've given you all the steps there, the shortcuts of how to take this graph and make it APA format. Right? To make this graph APA format. This, both how to run the ANOVA, the directions are right there in a separate document on the middle page. The steps on how to do this are there. I just printed a copy because I thought everybody would need it today. Okay. So do y'all want to race me? If you got a head start, kind of cheating. That's okay. If you need to add an element, over here, this little plus thing, I need a vertical axis. I need to add error bars. Now, when you add the error bars, you have to come over here and select the appropriate standard errors, and you need to do it for above. This positive means above the mean. There's also a line below the mean. We want the same thing in both places. If you select the whole graph, like I did, and go to home, you can say, hey, make everything on this graph times the around them and make it 12. And then I want to make sure that I take the border off of the graph. And that is properly formatted APA figure. Just for fun, I think it would look better if this fill was black or dark gray, and this fill was red light. And that is what you can copy and paste into your Word document. So you have your figure 1 document, you can just come down and make a new line. And one thing that I would suggest, another good habit to get into, is when you take this, when you grab this and copy it, okay, I recommend pasting it as a picture. If you paste it as a picture, it's going to make it really big. We don't want it that big. But if you resize it, everything moves together, right? Things don't get out of whack. Doesn't matter how big or small you make it. The resolution doesn't change. It doesn't get fuzzy, right? If you try and screenshot it, it gets fuzzy, right? If I just copy and paste this, now this is actually still an Excel file, and if I shrink this down, it gets all funky. The fonts don't change with it. I can move it, it doesn't move in the right way, right? So copy and pasting as a picture makes it static and freezes it, and that's sort of the best habit.
So how did you do that?
So you copy this, okay? And then you come over to your word, and under the paste drop down, you want to look for this picture. That makes it something that's not editable. Figure 2, check that off. All right. All you have to do is run your stats and make your figure 3. And as soon as you check off with Kate or myself, then that your stats are right and that your figure looks right. I'll see you Thursday morning. Sound good? Awesome. Doesn't always have to be so hard, right?
So you don't need a nice boxes,
No, because what are you going to call that? X color? I mean, it's kind of implied, right? I mean, you can put a text color, but you don't really need it. Yes?
I just need help with this.
Mhm.